There we go. All right, so here we go. We're going to start a 2-week series on kind of software engineering, and I'm going to bring my bent to this whole systems engineering thing. And so I'm excited about being here, and I'm glad you guys are all still sticking with this. I know I came in person when you had your thing here at Cal Poly at the beginning, and I think I met a lot of you there, but it was like 10 minutes long, and so, we're not very close. Didn't get into any deep conversations there, but it's great to see that you're still with us, and I hope you've learned a lot of cool stuff along the way. As I look at this, I don't know exactly what all you've done and what you've learned as you've gone. I've got an idea. I've looked through some of the slides and some of the content. I've talked to Kurt a little bit, but I think my goal is to try and not repeat a lot of what you've done, but definitely bring the software perspective and talk about software engineering, some of the, just an overview of how we view the world, which might be different from others involved, and maybe for many of you, maybe some of you, this is familiar stuff. Maybe some of you, you've heard some of the things, vaguely at a high level. Maybe it's totally new for some people. And so I want to get a feel for that as we go today a little bit and see where you are. So I have, let's see if I can do this. Yeah. I think Kurt always does kind of a check-in and reviewing your minute survey. I went and looked at the minute survey. I didn't see much there that I thought needed to be talked about, but let me just give a second. Are there questions on anything, on what's going on, especially with the transition, or any catch-up from last week, questions, follow-up that you have while Kurt is on that anybody has? I see some no's. Everybody's good. You had a good weekend, I hope. I spent my weekend in Kansas. That was a little crazy. Went out to see my son in college, and so it was different being in a different part of the country, but it's good to be back in California. Okay, well, here's my agenda for the day. Is I want to do a little bit on introductions, and part of that's going to be a little bit of me doing some storytelling. I think sometimes we connect with things through stories, and so I want to share some of my experiences early in my career, and that will lead us into a conversation on comparing process models in software. And you'll see a lot of similar things to what you've seen in systems engineering, but some maybe different vocabulary and definitely some different perspective on why we do things the way we do. And then I think you already started talking about the Agile Manifesto last week, and so I'll pick up on that. Maybe we can go through that kind of quickly. And then at the end, depending on what we have time for, I want to kind of probe you guys to see what are software engineering concepts and terms that maybe you've heard or curious about, or things that you'd like to make sure that I cover in these next several lectures or conversations that we have. And if we have time, I want to go over just a sample software project, look at some of the artifacts that we have, and talk about what they look like and why we do them. That may get pushed off to Wednesday, but we'll see. So that's my plan for an agenda. Any questions on what's coming today? Okay. Do you usually take a break still halfway through? I forgot to ask about that. Like at 5 o'clock, do we take a 5-10 minute break?
Yep, typically.
Yeah, typically? Okay. So we'll help keep me on track. If I forget that, if it's all of a sudden 5:15 and I still haven't stopped, feel free to let me know. Okay, so this is just in terms of introductions, since I kind of have the floor, I'll give you a little bit more of an introduction of myself. This is who I am. Very much family is important to me, so I put my picture of my family up there. I've got 4 teenagers between the age of 16 and 19, and so my life is a little crazy right now with all those teenagers and all of their activities. I did my undergraduate at a little college in Kansas called Tabor College, a Christian liberal arts school. I studied math and computer science both there. Went to University of Kansas and did my master's degree there. So I'm a big KU Jayhawks fan, love watching them play basketball. Often disappointed they don't go further in March Madness than they do. But that's some of my background there. I then worked at Sprint, and so you can see I just shared a couple of my business cards, and my very first real job was as an artificial intelligence analyst. I love telling my parents that, and they were like, "What is that? You don't have real intelligence?" They were just baffled by that. What is this artificial intelligence? And so I'll talk a little bit about that in just a minute. I worked there for about 5 years, and then got a call to come teach, which I enjoyed very much doing. Taught for 7 years of small college, Bethel College in Kansas. And then I went back to Kansas University and finished my PhD, and then came out here to Cal Poly. I've been at Cal Poly for 10 years teaching software engineering. I teach our software engineering capstone, which is a 9-month-long set of 3 courses, kind of like what you guys are doing, but it's very much a hands-on project that covers those 9 months, and we work with outside customers. And so this year we have 2 different sections. One of them is working with General Atomics, and so we're talking with Jared. He works at General Atomics, and so I might share a little bit more about the project we're doing with them in software this year. Last year we worked for Salesforce, and we've worked with Intuit and Local Scientific Drilling International, a variety of different companies in that capstone. Another thing that I do is I do a lot of entrepreneurial stuff here at Cal Poly. I work with their Center for Innovation and Entrepreneurship. Helped a lot of students start companies, and that's been very satisfying. I really enjoy that. A lot of that started when I started teaching Android courses back in 2009, 2010, when Android was first coming out. iPhones had just come out, and we were one of the first universities to teach Android. And so we got a lot of attention from Google, a lot of support from them. I wrote some grants from them, and out of those early days, especially, it was kind of easier for students to start companies when there were only 60,000 apps in the App Store, and they could create a company around a new app. And we've had some fun success stories there. One of them that's best known, a group called Punched, that got acquired by Google just about 6 months after they graduated. So I get a lot. I have students come to me saying, "Do that for me. Do that for me." and I tell them, well, there's no magic necessarily to that I can make it happen, but it's a lot of fun seeing them come up with ideas. And one of the ideas that I helped a student start, and I ended up becoming a partner, a co-founder with it, is this. We created a company called Steadfast Innovation, and we have an app called Squid. Formerly, it was called Papyrus. It's a handwriting note-taking app on Android. It's also on Windows, but we were primarily focused on Android. And it's been very successful. We've got over 3 million downloads, and we've been pre-installed on like the NVIDIA Shield tablet, and we have some other pre-installs coming. And so that's been a lot of fun working with some of the big companies, Samsung and Google and Amazon and Qualcomm, doing app development and thinking about monetizing apps. And so thinking in that space of startups and small organizations, comparing that to large organizations like working with General Atomics and defense contractors, things like that, very interesting contrast on how you do software engineering in those different environments. And so I'll try and capitalize on, focus on some of the differences in those different environments, what works in one place and what doesn't. So that's a little bit of just, where I come from. And I wanted to use that as kind of a launching point in talking about, here, I'll just tell some stories at the beginning from my time at Sprint. And as I go through these short stories here, I want you to think about what are pros and cons of these 2 examples of software processes that we used at Sprint. And we'll talk about that a little bit at the end. So this was back in my early days, right out of my master's degree, 1993, I think it was, through 97, something like that. 92 through 97, I was working at Sprint. I was in a group called Advanced Systems Engineering. You got to love it when somebody takes a title like that. It's like, oh, we're the advanced systems. Everybody else is just kind of the mediocre, the average systems, but we're the really advanced systems. In reality, there were a lot of really advanced systems in the company, but ours was a little niche group that was focused on calling card fraud detection. You can imagine in credit cards have this problem as well. Have any of you ever had identity theft or fraud on a credit card? It's fairly common, and it happens to a lot of people where whether it's just you're at a restaurant and somebody, a waiter takes your card back, they write down the number, they bring you back the card, and they go and they purchase a TV from Best Buy online with your credit card. And, it wasn't your charge. And so how does a company detect those things and notice that, oh, that looks fraudulent? We had that as a problem on calling cards. This is back before everybody had cell phones. And so people would, whether it was looking over your shoulder at a payphone or actually stealing your wallet and taking the calling card out of there, they would steal these calling cards and they would then make international calls for free. And it added up to a lot. Some of this is back in the day when it could be up to $2 a minute calling internationally to some countries. Yeah, it was very different than it is today. And there were drug dealers were some of the worst offenders. They like to, cover their tracks. And one way that they couldn't be tracked is by using somebody else's calling card, not their own. And so as a company, Sprint was losing about $1 million a day back in the early 90s to calling card fraud. And so this was a huge problem for them. When we say losing money, they were actually having to pay other companies overseas for the international bandwidth that they were carrying the lines. And so it was actually an expense that they were having to pay out. And prior to our group, everything was done on paper. They would get these reports that were 2 weeks old, and they would look through them looking for things that looked suspicious just by hand. So our job was to build a computer system that would try and identify those fraudulent trends and flag them right away. And try and get the data in near real time off of the switches when the calls, as soon as a call would hang up, we would try and get a response, get a record of that within a few seconds and look at that and see if it if we thought it was legitimate. And so we created an expert system, a rule-based system, and some of these rules were pretty straightforward. If somebody was calling from, for instance, a payphone in New York City within a few blocks of Grand Central Station, and they were calling United Arab Emirates, for instance, we were certain that was fraud. Okay, it was 99%, chance it was fraud. Other things were more unclear, like overlapping usage. So maybe multiple people are using the same calling card at the same time. Well, maybe that's legitimate. Maybe there's a family that's sharing that calling card, or maybe somebody has sold that calling card and there's all these calls going on simultaneously. And so we would have these different levels of rules, and some of them we could automatically shut down the card. Some of them we would route the next call into a call center, and somebody would, say, oh, can you verify who you really are? And that was kind of the idea. Well, the loss was so bad that we were just building a prototype and just trying to prove a concept, but anything was better than what they were doing. And so there was this tremendous pressure from management, throw the prototype into production. It's like we're losing our shirt here. We're losing $1 million a day. So get it into production, even though it's not production ready. Still, it's better than nothing. And so that was the situation that I came into when I started. Okay, and we're using the specialized hardware and all of this. Okay, so, and that plays into the story here. The specialized hardware is Symbolics. We're doing Lisp machines, writing Lisp code. And we and American Express were the two biggest customers of Symbolics, and we were both doing the same kind of expert systems in Lisp and using this proprietary hardware. Okay, so at the beginning, what we did is we had these consultants that were doing most of the work. There were only 2 Sprint employees on the team, and the rest were consultants, mostly from this company, Symbolics. And the process was they'd fly in on Monday morning, mostly from Boston. They'd stay at the Hilton, and they would work long hours because they were being paid by the hour. And back in the early 90s, $125 to $150 an hour was really premium rates. We were paying them a lot and paying all their expenses. And then they would leave on Friday afternoon. So that was kind of the context. What the software development process looked like there was, it looked very much like Agile. And that's partly why I want to tell this story. These were before Agile was known or popular. And And I want you to try and pick up on what was and wasn't agile out of this. They would do very short iterations. So they'd come in on Monday morning, maybe around noon, and they'd talk with kind of our user group who would say, what are the highest priorities of what needs to be done this week? And so they'd spend a couple of hours figuring out what they should work on that week, and they would then program all night sometimes and, code, and then try and get something deployed, put into production by Thursday night, so they could then watch it overnight and Friday morning and fix any defects, and then they'd get on the plane and leave on Friday. Okay? That was kind of their process of what they would do, and then they'd come back Monday and they'd start over again. So they have these 1 week short iterations, and each week they could find out what's the next highest priority of what we need to work on. It was very code-centric. They didn't have any kind of documentation. In fact, that was my first job when I got there. They said, we want you to spend however long it takes to document this, 500,000 lines of Lisp code. There's not a stitch of documentation on it. It's just source code. And so try and wrap your head around it and write it up so that we can pass it on and train other people about it. Okay? So it's very code-centric, no documentation. Global code ownership is kind of like anybody could change any code. There wasn't, oh, this is Joe's code and that's Sam's code, this is Sally's code, but anybody could change anything because they were often changing consultants. Sometimes we'd have a new group of people in each week. Okay? And the strategy was, let's just hire the smartest people we can and let's go as fast as we possibly can. So anything is better than what we were doing. So that was kind of the first process, and that was the case when I first arrived at Sprint. Then something happened, okay? A year or so into this, Symbolics, the company who was making the hardware, filed bankruptcy. And so now, all of a sudden, we're not going to be able to get this hardware that runs this Lisp language that we have all this code written in. What do? Do we try and limp along with old salvage hardware, or do we go to, kind of the more standard hardware that the rest of the software world is using? And so we decided we're going to have to rewrite the application in more standard languages using C++ and using a database. And so we developed relationships with Sun and Oracle. We hired local contractors that knew these technologies, and they were a lot cheaper, and they wouldn't just leave on Friday and then have different people the next week. And we went to the software development methodology of the day. And this is what everybody was doing, which was very much a waterfall development life cycle. And partly because the company was starting to talk about CMM. Does anybody know what CMM stands for?
No.
No? Okay.
Is that the same CMM as CMMI?
Yes, it's now, at the time it was CMMI, now, or it was CMMM, yeah, now it's gone to CMMI. There's a software CMMI, there's other versions, not just for software. And so what is CMMI?
I don't remember the exact acronym, but it's a way to kind of audit your processes to see if they conform and they have certain characteristics that you're following.
Yeah. It stands for Capability Maturity Model, and the I is integrated. And they have, like I say, a software version of that. And what they have in CMM is, this is a little bit of a tangent. We can get to it more later if this is something that really interests you. But they have levels. And in software CMMI, they have 5 levels, level 1 through 5. 5 is the most mature. And so, for instance, General Atomics is a CMMI level 5 organization. And in order to bid on certain Department of Defense contracts, you have to reach a certain CMMI level. Like you have to be a level 3 or higher, for instance, to even bid on certain contracts. And the different levels are judged based on how well you're measuring and managing your process. And so they have things called KPIs, key performance indicators, of metrics that you want to track to see how well are you adhering to your process, where are things getting out of whack and you need to address changes. And so they start out, even level 1 is just, do you even have a repeatable process? Is it documented at all? So that you could if you had a success, that you could repeat that success the next time because you know what your process is. And it goes all the way up to an optimized process where it's not only documented and repeated and it's managed, but it's also you're optimizing it where you're constantly looking at those metrics to see how can we improve what we're doing and getting feedback from the process as you go. So that's just a little bit of CMM. And like I said, today mostly in software, usually it's just people who want to bid on defense contracts are the ones that are going and getting certified for different CMMI levels. But Sprint was thinking about it at the time, and they were looking at defense contracts, and Waterfall fit well within that. Okay, so in the second methodology then, looking at Waterfall, what did that look like? We had, instead of these short 1-week iterations, we had long iterations now. Our projects would be 6 to 18 months long. And we'll go through the methodology a little bit. You talked about it last week. We'd have a big requirements phase, and we would think hard about what are the requirements, and we'd analyze it, and we'd build a design, and we'd review that design, and we'd get sign off on those things. And often in this waterfall, it would be about 40% of the project would be spent in terms of time and money before we actually wrote any software a lot of times. Okay? Very document-centric. We'd write these big functional requirements documents. We'd have these sign-offs. We'd have design documents and test plans and all of that. So the strategy there was to analyze and plan everything before we build it and to maintain some control over the process. Some of this comes from, well, I'll get to that a little bit later. I'll stick with my story. So those were kind of our two methodologies. So what were some observations we made as we looked back on them? In that first version, we produced a lot of functionality really quickly, but it relied on really highly competent developers. But we got quick feedback, and if we didn't like something, we could throw it away, and all we'd wasted was a week, and we could change. We could do something different. The downside was it was often poorly tested, and it would crash. I would remember this one classic Friday morning when I came to work, and these guys had been up all night on this big, feature that they were about to deploy, and they were just trying to convince each other that it was ready to go into deployment. We've tested enough. We're smart. We know what we did. It's going to work. I'm sure it's going to work. And they were just trying to convince and build each other up that it's going to be okay. Let's put it into production. And so they did. They put it in production. They watched it. It caused a little problem, but they fixed that right away. They watched it for a couple of hours, and then they left and got on a plane. You know what happened, right? About 3 p.m. when they're in the air heading back to Boston, it crashes, and I'm the only one in the lab now, and I'm trying to figure out what they did all week, and I can't get a hold of them on the phone or anything. And so I'm having to debug it and fix things, and I work on it for a few hours, talk to them on the phone when they land. We can't solve it over the phone. We end up having to back everything out and lost a lot of data and lost a lot of money that day because it just wasn't quite ready to go into production. And so that was, a classic example of what I saw happening in that first way of doing things. In the second way of doing things, we also had a lot of big problems that we were regularly missing deadlines, project overruns, and this was true of most of the software development projects of the day using Waterfall. And we're spending a lot of time just analyzing and thinking through the requirements and not getting anything actually built. Okay? It was hard to accommodate changes late in the process. If 9 months into the project, something in the market changed, that was kind of hard to go back and adjust documents. And some of the projects were even canceled before we got to writing code. We'd spend 3 months on it and hadn't written any code and cancel it. We also poorly tested these because in the end, we ran out of time to test them. It was a lot of what would happen. And it was already late, so let's just get it into production. So those are some of my observations of those two. So what are some pros and cons of those two things? What are some things that you notice? What's good and bad about them?
I think in the first iteration, the fact that you could rapidly iterate, you could discover a lot of new ways of implementing your code and create a lot of new methodology very quickly, and that's good in kind of an advanced development organization structure. But the con there, without any documentation, there's no record, and like when you have the company go under, you have to start over again, or you're stuck at square one. So there's risk involved.
Good. Okay. What else?
One of the things that jumps out at me, David, is the value of the super talented people.
Yeah. Yeah, and this first methodology was, even though I gave some examples of some problems, by and large, the company saw it as a huge success. They were getting a product out that was saving the company a significant amount of money. We dropped from $1 million lost per day to about $150,000 lost per day. That's a lot. That's a lot. And even if it was painful and buggy, at times, that was a lot of business value. But it did rely very much on really capable people, and we're willing to pay them 2-3 times the market rate because they were able to develop on a novel platform that was a good fit for this, and it was deemed worthwhile. Other thoughts?
I think that one of the cons of the first is because you had the turnover in employees and kind of the global ownership. It doesn't seem like they had the time to build like a relationship with the actual customer and the business unit. And like you talked about, it had a lot of similarities with Agile. That's a big component of it, is without that constant feedback. Like, it doesn't sound like they were the same. The people who were coding it were having feedback from the call centers who were monitoring the fraud or dealing with that, or actually operating the software.
Right. There wasn't good history that was being passed on from developer to developer. They didn't have a strong relationship with the product owner because it was different people pretty regularly. Mm-hmm. Yeah, good observations. Anything else?
David, there's one conversation that came up. One of our members in the class works out at Vandenberg. Nancy, she's not here today. But one of the things we talked about was a little bit about the nature of the consequences of, kind of the rapid, loose, try something, test it for a little while and throw it out there. Doesn't work in some systems that, a failure of a rocket is pretty consequential.
Right. So the domain matters. Some processes can work in a certain domain that won't work in another domain or application area. And so here, with the fraud detection, if fraud detection wasn't working correctly, most 99% of our customers wouldn't know. It didn't interrupt. They could still make phone calls. It was all after the phone call. Okay, it was just the customer that had some fraud, that they get a bill that's for $6,000, that they would know. Okay, what happened? How did it get to be $6,000? Why didn't you stop it before that? But that was a small fraction, of our users. That's very different from putting software on an aircraft or a rover that goes to another planet, or into a car, or any mission critical stuff, a medical device, where you send it out and it's deployed and it's hard to change, for instance. So different processes are different. Part of why did Agile come up, and what has it enabled that we'll get into, is the different kinds of products. What are products like now? How often do we deploy products? So what are some sample software products that we think of now? What do you think of? Yeah, apps. You think of apps on mobile devices. What else?
Just every time you visit a website. I mean, every time you visit Gmail, you're getting the latest version of that, and they're able to deploy that. without you ever installing anything.
Yeah. So web applications, things like Gmail, productivity stuff, calendaring, cloud-based software. So Gmail, how often would you guess that Google releases a new version of Gmail to the web? I think it's in terms of days, weeks, months, years. More often than years, definitely.
I'd go probably months.
Months.
Probably go days. I know they have different channels that you can subscribe to.
Yeah, they actually released, well, this was as of 2 years ago, and so I don't know what it is exactly today, but as of 2 years ago, they were releasing 4 days a week, Monday through Thursday, they would release a new version of Gmail. Okay, not everybody would see that new version. Sometimes they would, just release a version to 1% of their population just to test it, and then they'd roll it out to 5%, and then 25%, and then 50 and 100. And sometimes they would do A/B testing where they would release one version to one set of the population and a different version to another set of the population, and they'd study it. And they would collect analytics, like if they had a new little icon that you could click on that had some feature or something, and they might place it on the right or on the left, and they would see which one's better, which one did people discover more frequently. But they would release something 4 days a week. Okay, that's very different from the old days, when like Microsoft Office, Outlook, for instance, would have been released once a year, maybe every 18 months. And so part of that has been enabled because of Agile. And part of it is the tools. So we'll come back to that in just a little bit. Well, so that's some of the pros and cons there. Let's just talk about some of the different software life cycles. And this is going to look really familiar, I think. Standard phases would have been probably pretty similar in any kind of system. Requirements analysis and specification, design, implementation and integration, and then operation. And so you're deploying it then, putting it out into production. And so you have to operate it and maintain it. And then you might have changes in requirements, and you test at any phase of this. And so these are just, high level words. We might use slightly different words in different contexts, but the same general ideas happen in any kind of a design and development life cycle. Okay? We talk about the same thing in software. Okay, so how do we organize those different phases differently? And that's what I want to talk through here in just a second. We're gonna walk through each of these fairly quickly of different kinds of software development life cycles, and they range from being kind of an ad hoc to a very enterprise scale, predictive, being waterfall, being very iterative, being adaptive and agile. And so we can categorize these in different ways. And so we want to look at them, and each one we can place onto these different continuums. So some of these software development life cycles are very formal, and waterfall tends to fall on this formal side. But even waterfall you can do in a formal and less formal way if you want to. For instance, at the end of, once you have a requirements document done, how formal is that? Do you have to get 20 signatures? Do you have a big event where everybody comes together and they celebrate that, the requirements are done, we're now moving on, woo-hoo, we have a big party? Or is it somewhat informal that, they're pretty much done, we just hand them over, we think, we can make some little changes a little bit later on. How prescriptive and how agile the process is. And so again, there's a continuum along there. And how document-centric versus code being software-centric is the process. And so we can vary, we can plot each of our software development life cycles on these three different continuums. So the first one, this is kind of where we started, and many of my students still, this is where they start in their first year of classes, is a build and fix model. So you just dive in and start programming, start writing the software. You build the first version and you just keep modifying that until you think it's done. So you think it passes the requirements and it's done, and then you put it into operation. You deploy it out into production. Okay, so Some people will still do that. Obviously, it's very dependent on the competence of the developer, and it's very error prone. There's not many good checks and balances. There's no guarantee that you even understand the problem before you go in and start writing software with this. And so this is definitely not recommended. This is not the recommended practice, even though some people might still do it on an individual basis. Okay, so in the 1980s and early 90s, the software process that was most commonly used by development organizations was what we call waterfall, a very plan-driven, predictive process in which you would write the requirements, you would verify those, you'd have some quality assurance check to make sure that the requirements look done and complete, and then you would build a design and different ways. And so we'll talk about UML, for instance, as a way of visually creating a software design. And then you'd verify that. You'd have a software architecture and the detailed design. And these designs could vary. They could just have the high-level architecture and some design elements of how you're going to organize the code, or they could be very, very detailed and say exactly like what every single user interface looks like. You know, every button, every label on every button, every input, every output for the process. You could get it really, really super detailed. And some companies would go to that level of detail. Most of them wouldn't go that detailed, but some would. But then again, you would verify that design in some design review process. And then you'd move on to implementation, where you'd be writing the software, and then you would be testing that software, and then you deploy it into operation. And at any point, if you might have some kind of requirements change, you have to come all the way back to the beginning, modify your requirements, see what does that impact, change your design, see what does that impact, change your implementation, and retest, do what we call regression testing, and test the new stuff as well, and put it out into operation. Okay. What's interesting is this guy Winston Royce, who first proposed this idea of a waterfall development process. He actually proposed doing it twice, okay? Going through this process 2 times, taking the first half of the requirements and building it completely, and then taking the second half and building it completely. But nobody ever did that. Pretty much everybody, I think they just said, well, we've only got time to do it once, I think was the general idea. And generally, they would go through this once. But this was very common at that time. Okay. And it's still common in some organizations today. Okay, but what's the problem with that? There was kind of a reaction to that. There were a number of issues. And I really liked this when I saw it a couple of years ago, this idea of an iron triangle. So with this idea of a big upfront design, which is what Waterfall had, where you do all your design up front, what you're doing is you're fixing the requirements. Those are set. You kind of set those in stone. Our requirements are established. And then based on those requirements, you estimate the cost and the schedule. Say, okay, in order to do this system, it's going to cost us this much and take us this long. We're going to have to put this many people on it, and this is how long they'll spend on it. And so this is something that gets referred to as an iron triangle, that once those requirements are set, you can't change your cost and schedule very well. Okay, the requirements are established. Okay? And so what we're going to see is a reaction to try and turn that iron triangle around. But I'll go ahead and ask you, I mean, look forward, think forward. How would you change that iron triangle? What could you change?
Schedule.
Okay. So changing the schedule, are we saying, what I'm wondering is, can we change what gets fixed or set and established and what gets estimated? Do we fix the schedule? That's one approach, is we can say, well, we've got to be done by June 1, 2017, okay? That rover is going to launch that day, no matter what, okay? or for whatever reason, that's when, and and sometimes that happens. The Olympics are coming, right? And they're going to start whether the software is ready or not. So what then would you estimate? Would you fix just the schedule and then estimate the costs and the requirements? And how would you do that? What would that look like? And that's kind of where we're going, okay, is can we flip that upside down? Okay, so let's keep going. So different approaches, one of them is rapid prototyping. Rather than writing a big requirements document, sometimes we can't think through it all in our head. We can't just write it all down in a requirements document. So we need to build a prototype and get some feedback. And so that's this concept of rapid prototyping. Build a prototype quickly and verify that it's feasible, that yes, this would work for if we would expand it, extrapolate it out, it would work for the final solution. And so then build a design based on that prototype, what you learned in your prototyping. Okay? And then go and implement the real thing, the production thing, based on what you learned in that prototype and what you designed from that and put it into production. And so this is just a small kind of high-level overview of this. There's a whole process around this, but that's just slight variation on that. Rather than diving into a requirements document, we build a prototype in order to explore the requirements. Okay. Then these ideas start coming out of incremental and iterative development processes, okay, where we still maybe build the requirements, we investigate what those are, and we build an architectural design, but then we go through iterations or increments. We'll talk about the difference there. For each build, we'll design, implement, test, and deliver some portion of that development. And so what does that look like? So incremental looks like this, where maybe we take one set of features and we go through all of this design, implement, test, and deliver here. And then another set of features, design, implement, test, and deliver. Another set of features, maybe it's just one feature at a time that we'll do. And we can even stagger these things where maybe we have one designer and they work on the first feature and they hand it off to an implementer, and then they go on to the next feature and hand it off to the implementer, and so on. So one designer works on all of these, just a little bit at a time as you go. Okay. Or maybe we do it consecutively where the whole team, we're going to go and design, implement, test, and deliver one feature, and then we're going to do the same thing for the next feature. But the idea with incremental is where we take one feature, then we add another feature, then we add another feature, and we add another feature. But we do it in the context of we already kind of have an idea what the requirements and the general design of our software is going to be. And then iterative is similar, except that we can revisit the features. It's not this concept of we build on the next feature and the next feature. It could be that in our first iteration, we build a feature, and then in our second iteration, we say, oh, we didn't like what we did. Let's totally redo it. And we go and revisit that first feature, or we change half of it. So we don't consider that a feature is done and move on in iterative. We can revisit everything each step of the way. Okay. That's kind of the slight difference in how we talk about incremental versus iterative. And iterative is what's common with Agile. A predecessor to Agile was this thing called the spiral model. Not a lot of people used it, but I mention it here just because it exists. And it's the same concept where you do a little bit of requirements and you do some risk assessment and you evaluate that, and then it just keeps expanding and expanding. You go around the circle of doing some requirements, design, development, testing, and you just kind of allow the whole thing to keep expanding. And the key difference in Spiral is you've got this risk assessment phase that at each point you check to see what's the risk of doing it this way versus the other alternatives. Okay. And I won't go into that a lot just because it's not used widely, but it's out there. Okay, so then we get to Agile. So the history of this is you come to the end of the 1990s, and there have been all of these, almost everybody's using a waterfall process, and they're long projects. They're often over budget, and they're late, and the software developer is getting frustrated at being yelled at for being late, and they want to change. So a group of thought leaders gets together in Utah, and they say, okay, there's got to be a better way. And they come up with this thing called an Agile Manifesto. And so they say, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value these things on the left. They value more individuals and interactions over processes and tools. They value more customer collaboration over contract negotiation. They value more working software over comprehensive documentation. And they value more responding to change over following a plan. So that is, while there is value in the items on the right, we value the items on the left more. So maybe this is our last, before we go on, we'll take a break here in just a minute. What are your reactions to that? Do you agree with that, or do you think, do you question that?
If you're a systems engineer at JPL and you have for a long time followed a very strict waterfall engineering sequential model, your reaction to this would be, this wouldn't work in our world.
Right. And why do you think that is? Because of lack of familiarity or fear of the change, or because of confidence in what we know and what has worked for us? Or
Seems like all of those.
Yeah. Okay.
Yeah, it's so I'm witnessing this going on at JPL, where they're trying to move to a different way to do the systems engineering work, and it's largely being returned that way won't work. Of course, I'm not sure that's correct.
Mm-hmm.
Is it just the culture there that's really been driving that, I guess?
Yeah, I think that's a big part of it.
Yeah, I would say there's a lot of quality certifications that require you to have working procedures documented fully and fleshed out. So there's that on top of that for business units. But I think the company will want to be certified, but it's more important to have the functional software, I think, for the most part. So that's more helpful to be an agile working company.
Yeah, that working software, this third one here, I think most people would say, if you said to a software developer, and the software developer might say, well, which would you rather have? Do you want to have working software, or do you want to have comprehensive documentation? And you can't have both. Well, most people would probably say, well, I want working software. I want it to work.
Yeah.
Probably that's what they would say. In most domains, I think that's what we would say. But they might say, but I really want both. Yeah. One of our problems, so I had a guy, Robert Martin, who was one of these thought leaders. He actually signed on my Agile Manifesto, and he came and he spoke at where I used to teach. And one of the first things he told my students, which just made me cringe, was documentation is all lies. Comments in your code, they're all lies. And I'm like, oh, I've been teaching my students to write comments in their code and document their code, and here this, prestigious guy comes in and tells them just the opposite and just ruins everything I've been teaching him. But he went on to talk about it and explain it. And his explanation was that a comment in software can never be verified. It can go out of date, and there's nothing that checks it, okay, except for humans looking at it, reading it, and thinking about it. But there's no programmatic, automatic way to check the comments or the documentation to see if it's up to date, is it current. But with software, you can run it. You can execute the software and see what it does. It's always up to date. Whatever it says it does, or in the code, is what it actually does. And so there's no lies there. If there's a bug, if there's a defect, then it's there. It doesn't lie about it. You know, the documentation might say it does one thing, but in reality, that's not what the code does. And that's where you have defects often. And so that was his complaint. And that's one of the problems that a lot of people with waterfall and document-centric processes often have, is those documents, how it's so difficult to keep them up to date and to keep them in sync. You know, when you make a change here, does that affect 3 other things over here? And did you remember to change all 3 of those things? And then producing new versions of them. And so there's been efforts to create tools to help simplify that. And you can have traceability tools that can trace, oh, when you change something here in the requirements, that's going to change these 2 things in the design and this thing over here in the test plan. And that can help you know when your documentation is out of date or isn't in sync. And so there have been tools that have tried to address some of that. But this is the conflict. Any other comment before we go to a break? Any other thought? Agree, disagree with Agile Manifesto?
David, I'm looking at the second bullet point, and you know, customer collaboration, that sounds great, over contract negotiation. And I would think that, you know, some organizations would say, well, we can't spend a lot of time collaborating with customers if we're not making a profit here at this company. And so I would think that there might be a negative, what, you mean we're not going to get paid for doing the collaboration?
Right, right. And let's define who we mean by the customer there. In that, what we're referring to is who's paying for the software, most likely. And so often that's like a product owner, a product manager, not a project manager, but a product manager. And so we look at places like Facebook and Twitter, and so like Gmail at Google has a product manager, somebody who's over Gmail and decides what features are going to go in, and they represent the customers, or the users, maybe you would say, people that are using the software, and they establish priorities. And that's who the software developers are collaborating with to know what's your next highest priority. And so, you know, this is an interesting one. It's great that you pulled that out. I've been in situations where we write contracts, and then when you get to the end of the project, is it done? Okay. Well, things changed along the way. You know, maybe we made the customer said, this is more important than that. And maybe we added something and took something away. And in the end, it doesn't match the contract exactly. So if it's focused totally on contract negotiation, then everybody's going to be unhappy. But if it was a collaboration with the customer, and each point along the way you agreed, yes, we'll do this, we'll make that a priority, this priority. It gets to the iron triangle, I guess, is what we're going to get at. Is that here in our next one?
How do you respond to change without comprehensive documentation?
How do you respond to change without comprehensive documentation?
Yes. So if you have working software and it's just a black box, and somebody wants to change something, but you don't know how to change something because you don't have documentation.
Right. Okay. Yeah, good question. So one thing that I think the Agile camp would say is the code is the only accurate documentation. And so if you want to see what it does right now, you read the code, because the chances are the comprehensive documentation might not be right anyway. And so it requires competence of understanding, being able to read software and understand that. And that can be a challenge. Do you have enough people that are competent to read that software? But those are the people that are going to have to be making the change anyway. And if they can't understand the software they're going to be changing, then you're already in trouble. is what the Agilists would say. I'm not sure if that answers your question. Feel free to ask more.
Yeah, I think I got it.
Yeah.
And so it's Jonathan used the word black box, but it's not that the software is a black box. You can
Right.
open up the source code and look at it, right? So
Right.
it's not just a compiled executable. So there is access to I'm trying to think of the analogy because Jonathan is a hardware engineer at
Mhm.
Tesla, so he's dealing with automated machines that sometimes come from contractors, and
Right.
those are black boxes to him.
Right. Yeah, that makes perfect sense. Yeah, if you think of a hardware like a chip, um, an integrated circuit, a chip that you can think of that as a black box, but if you've got the design of that thing and you can see all the circuits and you can go and modify those circuits and then print a new chip, then you can see inside that. It's not a black box anymore. You can see how it's designed, what it does. And that's what we think of software as, Yeah, we can talk a little bit more about libraries and getting off the shelf software and things that do look like black boxes where all we have is the executable. We don't have the source code. And,
And David, back to the second one we were talking about. So I was thinking a little bit, Brad works at a software company, and so that, their customer are the users that are paying for the development of the software. And so I think they value a lot the interaction, and the customer comes with new requirements and new features and things like that. But I think that if the contract isn't negotiated and it's not in place, then it's hard for his company to dedicate resources to work with that customer.
Mhm.
So I was still thinking, I don't know that there's something to answer, but I was thinking about the balance of those two things.
Right.
It's definitely tough. Our military customers, they have a change control board and all these other things that go along with the software that they like to have control over it. But I talked a little bit about last time, but we kind of try and have them state the contract and the requirements in such a way that they can be interpreted differently as we go through each sprint and decide like exactly what that implementation is going to look like, and then tweak it the next sprint or go through that and still be able to have the business people and the contract office sign off on it and say, okay, you got the capability to do blah. And that's been a long process trying to get the contracts to not say like, you will have a window that has a button here that does this, that does that. Like that removes that agility or that flexibility. So where possible, we try to make the contract in such a way that you're fulfilling use cases and you're not, giving like explicit, kind of requirements up front that can't be changed later on. But there still comes at the end of it, when we ran out of money and we ran out of time and they want a new feature, that's when everybody goes back to the contract and says, oh, that's gold plating, that's scope creep. We don't do that.
Yep. Yeah, it's great. Those terms, gold plating. So adding things that the customer didn't ask for. Scope creep, the customer asking for things that weren't in the original requirements. Those are kind of two sides of the coin that both end up causing problems. Yeah.
They're all okay until the last sprint.
Okay. Well, I'll tell you what, we're at 5:11. Let's take like a 5-minute break. Is that okay? 5:16 by my clock, and I want to wrap up that part of our conversation in just a minute. So 5 minutes.
Hey, David, I wonder if you were recording that whole time. I didn't even think about it.
Yes.
Okay, great.
I hope I am. Not sure I tell. I know I clicked on record.
There might be a red button that illuminates, it blinks.
Yeah, that I'm not seeing, but I do see when I go to that overflow, it says stop recording now instead of start recording. So I assume I am.
Okay.
Yeah, thanks for asking. All right, I got 516. People are starting to come back. So let me just mention something on that last topic real quick of customer collaboration versus over contract negotiation. I've had several, so I have this little company, we have this app, and we've also done a couple of custom apps for other companies along the way, just to help supplement revenue early on when we were getting started. So the story of one of the first ones, a single guy that came to us, so not a company, just one guy who had an entrepreneurial idea, and he said, I want you to build this thing. And he gave us a short vision. And he wanted to know, what's that going to cost? You know, you get that question a lot. What's that going to cost? Well, okay, you just gave us, you know, like a 2-paragraph description of what you want it to do. But that's not nearly enough detail for us to estimate exactly what it's going to cost. And so would you like to go through and get that amount of detail so we can estimate what it'll cost? So he wanted to do that. And so we start to do that, and it turns out he really doesn't know what exactly he wants. And so the more that time we spend trying to flesh out and give him ideas of what it might be, well, now we're putting a lot of time into this and effort into this before we even have a contract in place. So we put a contract in place just to cover time and materials, a certain amount of time to help explore what the requirements might be. Eventually, it just evolves into, well, let's build a prototype. And then I think we'll get a better idea of what we want. Oh, well, I kind of like this and I don't like that, so let's throw that away. And so it turns into very much a open-ended contract because it was very difficult to establish what the customer wanted early on in a lot of detail. So that's very common these days, where in the app world, where things move very rapidly, in the web space where things are constantly changing very quickly, nobody can say exactly what they want for very far out in the future is kind of the problem. And so either you spend a lot of effort writing a lot of short contracts, which sometimes happens. Well, let's just do a 3-week contract because we know we want this. And then we'll see in 3 weeks for sure what we want next based on what we've learned on this. Sometimes we do that. Or we have more open-ended contracts where there's just a lot of customer collaboration. So what happens in places like the JPL, and defense organizations, you're building an airplane, a fighter jet, whatever it may be. This is a long-term project, and they set out at the beginning with certain goals, and they do spend the time in order to flesh out all those details. But it's a big process just to get all those details down on paper and then to be able to make an estimate based on those details. So partly it depends on your domain. And most software these days, I would say, is built in the former domain where the space is changing somewhat rapidly. Most people can't say 6 months, a year from now, exactly what they're going to be needing at that point because things are changing somewhat rapidly. It depends on your domain. And many of you in systems probably work in places where you can predict a year from now what your product is going to be. I don't know. I mean, give me some quick feedback on that. How far out can you predict what your product should look like in your domains? Can you establish requirements and say, a year and a half from now, this is the product we're going to want, and we're quite confident it's not going to change in that year and a half period? Some of you probably can say that. I don't know. Can you?
So David, I'm thinking about one of our classmates that isn't here, Yuka. She works for a startup medical device manufacturing company, and they've put all their effort into kind of their first iteration. So I would say in their case, it's probably very difficult to predict what the future a year and a half is going to be. Yeah. But then some of the others that seem to be tongue-tied right here have pretty stable, well-established products that they design and iterate on. Like we could just say, like, ask Garrett specifically, Garrett, what about your products? Garrett, are you with us?
Oh yeah, sorry. The microphone was unplugged. I think
you might just give David a quick overview of what you guys make there.
We make fiber optic test equipment, so testing the return loss and just more or less and the interfaces of cables. What was the question again? Sorry, I forgot.
Yeah. So can you predict, how far out can you predict exactly what you would want, at least your software, but in general your product to be exactly what the features would be? Can you predict out a year and a half and say, the world's not going to change in any big way between now and then, and you can be working for the next year and a half on something and still be confident you'll be delivering a product? Or might it change between now and then?
We can usually predict someone that's more sales that's doing that, doing their market research.
Right.
And so then we can work towards that goal and not change it too much. Little slight tweaks here and there once we kind of deliver the prototype. With the software, I know that's a little bit more stable. And when they start, or I think it's more stable when they start setting out what they want to do. I do the mechanical side of it, so I'm not really involved as much on the programming.
Okay.
But I know that we do they do meetings weekly trying to figure out like what they have done, what they haven't done, and what they want and don't want from the programming.
Right. Okay. So the point that I'm trying to make is that how much change can you accommodate, and how much change do you want to plan for? If you don't need to plan for very much change, you have a little more flexibility in how you do software, your software process. If you need to accommodate more change, that's where Agile came in. In fact, we're going to talk in just a minute about extreme programming, and the subtitle on the original book on extreme programming was Embrace Change. So rather than being afraid of change, and that's what happened with Waterfall is, we didn't like change, we were scared of change, because if something came up after we'd already set the requirements, it was a real hassle. It was very expensive to go back and change things. And that wasn't working well in general in the software community. Things were changing too frequently, too rapidly, and so they needed a process that accommodated change better. Okay? So I think that's one of the good tests that you can use to look at your organization is how much change do we need to accommodate? If you need to be able to change quickly what features you're building and what those are going to look like, then you probably need a slightly more agile process. If you don't need to accommodate so many changes, you can probably get by with a more planned, more prescriptive driven process.
So David, before we move on, I'm so interested in these concepts and these ideas that, I keep translating them to systems. And many startup companies, there's a good story of Aeromech here in San Luis, which was some Cal Poly grads that started building UAVs for indirectly the military. And the thing they were so great is they were really fast, right? The Air Force could call up and say, could you do a little airplane that does this? And in a few weeks, they would deliver a prototype. And so, that started where it's an agile company developing systems that has software in it, but they're developing the hardware too, and the operating procedures. And, over the years, as that company grew and then eventually got bought out by Lockheed, well, now they're back to that very rigorous, bureaucratic waterfall organization that's there. And there's even some great stories that go way back of Lockheed Skunk Works developing complete airframes and complete airplanes, in very rapid 8-month cycles. And so I do think it's, these concepts are possible, but it seems like these days the culture and the structure of the military industrial and the DoD kind of mandates that waterfall process.
Right. I'll give a related example. So with the handwriting app that we have, for instance, a manufacturer from Korea who makes basically like really large TVs that are like tablets, and they have a pen like a marker that you can write on these tablets in a conference room. They're up to like 8 feet in diameter and across. They came to us. They'd probably rather work with Microsoft's OneNote, is my guess, but Microsoft is too slow in being able to respond to their new technology and incorporate changes. Microsoft has to please lots of different people, and they're a big organization, and they would rather work with us, even though maybe we don't have the same feature set. Because we're more agile, we can respond more quickly, we can integrate things faster and be responsive to them. And so for us, it's crazy that we're a little bitty startup competing against really big companies. Our primary competitors are Evernote and OneNote from Microsoft. And these are really big companies. How could a little company succeed? And yet we are, primarily because of being agile.
And David, I wonder if you're familiar with design thinking from the guys at IDEO.
Not much.
But it's basically an agile hardware development process that is, let's throw a prototype together and let's go try it, and then let's take a little iteration very rapidly. And so to me, that design thinking is very much an agile process.
Right. Yeah. Okay, so the thing we'd like to, I think that's a great segue to this next section. The thing we want to think about is if that can be really beneficial to iterate quickly on things, how do we make sure it doesn't get out of hand? How do we keep it under control so that we still get a quality product, so that we still have knowledge of what we've built and we can change it in the future? You know, if I go back to my sprint example, we don't want to be in that first process model where it was great because we could develop things quickly, but it was terrible because it was poorly tested and it was often low quality, and there wasn't good consistency in knowledge, transfer of knowledge on there. How can we address some of those things? And that's what XP in particular tried to do, extreme programming. So let's get to that here in just a second and see what some of these practices are. Is that okay?
I think Brad was trying to say something.
Okay.
I think I talked over Brad.
Yeah.
Oh, no, I was just gonna say that one thing that helps me kind of to explain this to other people when I talk to people that don't necessarily work a ton in software is think about the difference between, like software as a service and then just like buying a product, like the evolution of that. And to me, it's kind of a natural translation. It's almost like development as a service is a reflection of the fact that we're now, delivering software as a service. Like, I use Gmail to handle my email and all of that, but I don't necessarily I didn't buy a version for $20 and it's static forever, but I expect it to evolve and oh, look, now it integrates with Papyrus, this new thing, or Squid, or,
Yep.
I just opened up Word Online, the other day, and it was oh, look, now you can open directly from Dropbox and do those things. So that's kind of where you talk about, and if a new product blows up, it's hey, how come in Gmail I can't why doesn't it integrate with if this then that, and then do something with Slack, or it's just you can't really predict what's going to be there, so you just more want to evolve it around this is a capability we're giving you, but the specific feature set or those things are all going to change, and in order to accommodate that, it's more like a service than it is I paid you $50 for these 10 features. It's more of I'm trusting you to give me a note-taking capability, and that's going to evolve over time to be what it's going to be.
Yeah, that's a great example. And one of the things to look at there is the economics, in particular of the app world. When apps first came out, there were a lot of paid apps, $1, $2 apps that you would buy. And many of those apps were things that you would just use once and they were kind of done. But now that's changed. We use apps continuously, like Gmail as an example, but things that we'll use regularly, and we expect them to keep evolving and keep adding features and keep getting better. And so economically, it doesn't work to pay one time and then expect to keep getting new versions and new versions. Years ago, Microsoft never would have sold us Microsoft Office 2009 and then provided for us 2011 and 2013 and 2015 for free because we bought it once back with 2009. They sold us the new versions every time. Okay, we had to pay again. And so the app world is now changing. The economics are changing. There's more and more apps that are moving towards subscription models, where if it's an app that is going to keep being updated, you keep paying for it. Like Microsoft Office is an example. They've moved to totally a subscription model. And you assume that they're going to keep adding new features and they're going to keep developing with that. And so the economics are part of what drives this. If you think about in hardware and in systems, like you're building Tesla, okay, I would love it if I could go and buy a new Tesla, and like the app world, whenever they come out with a new model and they do upgrades, they're going to send me a new one for free because I already bought it once. Okay, but they're not going to do that. Okay, I'm going to have to buy the new model when it comes out because it's hardware, and yet it's the same concept of development effort in software. And so the economics are part of what plays into this. And so the idea of as a service, software development as a service is a good one. You're going to want to keep upgrading it, keep changing it, keep improving it. We don't have many products anymore that are ever done, done and finished. Okay, I want to get to a little bit here. I think we've kind of talked about this, a little bit of historical perspective, how it fits in, and was this a knee-jerk reaction to the waterfall method, and did they go too far? So this idea of the iron triangle, so Agile supposedly inverts this iron triangle. So whereas with waterfall, we fixed the requirements and then we estimated how much, the schedule and the cost, essentially the resources and the date. In Agile, instead what we're saying is we're going to fix the schedule and the date, and we're going to let the requirements vary. So usually what this means is we'll say we're going to do a 2-week iteration, and we're going to have these 10 developers working on it for 2 weeks. And so we now know what our schedule is. It's 2 weeks, and this is our cost. It's 2 weeks pay times the 10 developers. Now, the customer can then say, the product manager can say, what do you want done? What's your highest priority of what you want done in that 2 weeks? The schedule and the cost are set. You decide what you want done in that schedule and cost. And then you extrapolate that out over 6 months or a year or whatever you decide. And you can do some high-level estimates of what you think this application, the software is going to take. Oh, that looks like about a 6-month or a 1-year project. But in reality, it's very, very difficult to accurately estimate that. And so instead you say, this is our schedule and our cost, and we'll give you the best that we can in that amount of time. So there's a certain amount of trust there. And that's scary for customers. But that's what we've moved towards in Agile in many ways. Okay, so I want to look at one of the first really popular Agile development models. It was Extreme Programming, XP, because many of the practices from this continued on. There's still some groups, especially in Europe, they use XP a fair amount, but in the US, it's more been overtaken by Scrum. And Scrum uses a number of the practices. And so this just gives you a little bit of a historical perspective there. Kind of talks about who are the big thought leaders here, Kent Beck and Ward Cunningham, about when did it come out. Typically, this is for small teams. And so the initial criticism was, oh, that doesn't scale up. This is great if you've got like 10 people working on something, but if I'm Boeing and I've got 500 software developers working on my next, big aircraft, the avionics or whatever, how does this scale? And they've come up with ways to scale it since then, but originally it said, oh, we don't do that. It's small. But we had these different roles that it defined. Who's the customer, who's the coach, who are the programmers, the tester, and who tracks the progress, and these values and core practices. And so some examples of these best practices and why they called it extreme programming. As Kent Beck said, it's like taking your stereo dial and turning it all the way up to 10. We're going to do software in the extreme. So the first one, the idea that if customer feedback is good, meaning it's good to show our software to the customer and get their feedback and see what do they say. Do they like what we're doing so far? Do they not? And how frequently do we get that feedback? If we only do that once a year, that's not very often. Once a month, well, how often should it be? Well, the extreme thing would be for them to every day, all the time, be watching what we're doing. And so the idea of a customer being on site was the extreme idea there. And they can, at any point, you can go show them something. They're checking in. You can see what's going on. Another good practice in software development is code reviews. I write some code, I write some software, and I ask another developer to look over it. maybe the rest of my team, maybe 5 people are going to look over it. They're going to say, oh yeah, that's good. Oh no, this looks like a security problem. You didn't follow our code style conventions, whatever. So how often do you do those code reviews? Problem is, it takes too long to do code reviews. And so even in good, mature organizations, it's often only about 5 to 10% of your code gets reviewed. So the extreme case would be, we're going to do pair programming. 2 people at one computer writing all the code so that they're constantly reviewing each other's code. It's like we're always doing a code review as we write the code. That's the extreme version of code reviews. Next one, if early integration is good. So integration meaning like I've got 20 people writing software, and at some point we need to bring all of that software together and test it together and make sure it works together. So if doing that early rather than late, the problem with Waterfall was we sometimes wouldn't integrate our code until the end of the project, pretty late. Well, then we'd find all sorts of issues that we should have fixed a long time ago, and so we want to integrate earlier. So the idea here is continuous integration. And now we're on extremes where we're integrating, often teams are integrating every hour. It'll check out what the latest code is. It'll run a bunch of tests and see, does it all compile together? Does it all run? Do we break anything? So you know very quickly if what Joe's working on is messing up what Sally's working on. Rather than 6 months later, we know right away. The last one, and this is where I did a lot of my research in my PhD, is on automated testing and test-driven development. Unit testing, the idea of unit testing in software is like if I write a little function, and I guess I'm recognizing many of you, maybe none of you have written any code before. Some of you have probably written a little bit of software, and so maybe you don't know what I mean when I say write a function or write a method, an operation. So I'll show an example of that here, probably not today, but later in the class. But if I write one little piece of code, a function, I want to test that and see if it does what it's supposed to do. Then I might write another piece of code in a unit testing framework that makes it easy for me to test that, to run that piece of code, the first piece of code, and see if it does what it was supposed to do. If I give it a 20, does it give it back false? Or whatever it's supposed to do. So the problem is we often don't write the tests because we run out of time. So in the extreme way, we're going to write the test first, what we call test first development. Before you write that function, you have to write a test that will tell you when you're done with the function, when it works correctly. And that's what they call test-driven development or test-first design. And it actually drives your design. So those are some examples of doing things in the extreme. Here are kind of all of those. I mentioned test-driven development. I mentioned pair programming, continuous integration. These are all of these core practices that are a part of extreme programming. I won't go through all of them, but that's basically the idea there. And then they had these values as well, that they value communication. These are different ways that we communicate amongst the team. Simplicity, they use this term YAGNI, you ain't gonna need it. And so that it is meant to combat gold plating, like was mentioned earlier. Only do what you absolutely know you need to do right now for this iteration. You might think, oh, it's really important to make this more flexible, more modular. Later, we're going to use that. But chances are you might never get to that. And so why waste a bunch of time now doing that? Let's just do the simplest thing we can right now. And then when we actually find out we do need to make it better, make it more flexible, then we'll invest the time in doing that. That's one of the XP principles or values. Feedback. The tests tell us what's worked. We use these things called user stories, which we'll do some examples on Wednesday of that, and so on. Courage. One of the things about tests, so writing automated tests is one of the most important things that became common with extreme programming. And so now, not only do you have the software that you've written, you have a set of software that tests your software. And you can, with a click of a button, you can run all of those tests and you can find out, did I break anything? Do the tests all pass? And that's what gives you courage. Then you can go and you can make a little change. And you can run all your tests real quick and find out, did I break anything? And that gives you courage to make changes, even in code that you might not understand really well. it's somebody else's code that you need to change, for instance. And then respect is the last one. So that's a little bit about XP. This is what the flow looks like. You do these iterations. You have a planning game at the beginning. During the iteration, you figure out what are the user stories or use cases we're going to implement. You use pair programming, test-driven development, and refactoring throughout that iteration. Then you release something to the customer. And maybe they release it out to the users. Maybe they just say, oh yeah, that looks great. Or no, let's change this. And they go on to the next iteration. And you keep going as many iterations as are needed. You do this continuous integration throughout. It's just kind of a visual of what that flow looks like. But you can see the customer is very involved. At the beginning of every iteration, they get to say, what's the next priority? In some cases, people didn't like this. Customers didn't like this because they wanted to be able to just say at the beginning, go do this, and then they disappear. Here, they're expected to be a part of it, and they have responsibility in how the application evolves and changes as you go. And so it's more work for the customer. All right. Any questions on extreme programming?
So in a Scrum framework, would an iteration in the XP framework be considered a sprint?
Yeah, basically. In Scrum, we're going to see Scrum next in just a second, and they have these things called sprints, and basically they're iterations.
Okay.
Scrum was inspired by extreme programming. That's where it came from. Good question.
I think it was Jeff Sutherland who developed it, or
was very involved in initial work of Scrum and kind of an evangelist for it, letting other people know about it and teaching them about it. Yep.
Mm-hmm.
So you want to go to Scrum. Let's go talk about Scrum then. Okay. So this is what you hear the most. If people are doing Agile, most likely this is what they're doing today, is this thing called Scrum. You've got this concept of a product backlog where you have generally they're user stories, and we'll look at what a user story is on Wednesday, how you write them. But they're things that the user wants to be able to do in your application. And the product manager will prioritize those at the beginning of a sprint and say, okay, we're going to do a sprint. Usually they're between 2 to 4 weeks, and you set the date at the beginning of the sprint. Say, okay, this is going to be a 3-week sprint. Okay, and you pull off the backlog and you prioritize those user stories, and there's a little activity in sprint planning that goes on there in which the product manager says, these are the user stories I want, and the development team is right there and they estimate very quickly how long they think it'll take to do each of those user stories. And so the user stories have to be relatively small so that they can estimate them and so that they can complete like 4 or 5 of them within 3 weeks. So they can't be that big. And based on those estimates, they'll kind of come to an agreement of what fits and what doesn't fit. And they might establish what are called stretch goals. So maybe they'll say, well, we'll commit to these 4 user stories that we're going to finish, and then we're going to take on 2 more stretch goals that if everything goes really well, we'll try and get those done as well. And so then the development team will go off and for their 3 weeks and they'll work on it. But during that 3 weeks, every day they'll have a daily Scrum meeting. And during that daily Scrum meeting, and sometimes, if the team is distributed, they might do this virtually. But typically it's called a stand-up meeting. And the reason they stand up, well, why do they stand up? What do you think?
Because you want to get out of there, so you're going to not be comfortable and sit down.
Exactly. You want to keep it short. Otherwise, there's a danger of somebody might talk a long time about something, and before you know it, you've spent a whole hour. You want to keep these things down to 5 or 10, maybe 15 minutes at the most. And you answer every person in the team. You just go around the team and you answer 3 questions. And the 3 questions generally are, what did you do? It depends on when you're doing it. Let's say you're doing it at the beginning of the day. So your first question is, what did you do yesterday? What are you going to do today? And then the third question is, and what struggles or what roadblocks do you have? Sometimes the questions look a little bit different, but they're all basically that same thing. What did you just do? What are you about to do? And what problems do you have? And it's amazing how much gets solved just by asking and answering those 3 questions by everybody in the group. Some of the big advantages are you all know what everybody's working on. And sometimes you find out, oh, you're going to work on something. I was going to work on something that involves the same software. Let me wait another day and I'll let you finish what you're doing so we're not kind of stepping on each other's toes in the code. So there's some coordination that happens. Or there's learning that happens. Somebody will say, oh, I've got a problem. And somebody else will say, oh, yeah, I had that problem 2 weeks ago. I know how to fix it. I'll come help you later this afternoon. And so a lot of problems get fixed in these little daily stand-up meetings. And I think they can be great, not just in software. I think they can be great on any kind of a team. I think they've been very effective. Some students use Slack for doing these kinds of things, or just email or texting, or different instant messaging. I've seen teams use a variety of tools, but in person is great. At the end of that 3 weeks, then you have what they call a PSI, a potentially shippable increment. So something that should be complete. If a user story is accepted as finished, it should be shippable, meaning that it's totally done. It's not just halfway done. It doesn't still need more testing. You've done everything there. And so at the end of any sprint, each of these is a sprint, you should be able to ship that version of the software to your user, is the goal. So at a high level, that's the idea of Scrum. Here, just one more slide on Scrum. Some things about the teams. They're self-organizing teams. There's not necessarily a team leader. Everybody on the team can collectively say, oh, I'll take this task, I'll take that task. There's nobody who's telling everybody else what to do. That's what's typical of Scrum teams. They're cross-functional, meaning that they perform all aspects of the work. And so if you need somebody who's dealing with the database and who's dealing with this interface with the hardware, and somebody else who's dealing with the user interface, they're all on the same team. You don't have separate teams and you hand it off. Oh, that's the UI team. This is the database team. Instead, they're all on the same team working on some feature together, is what's typical in Scrum teams. And then there's these 2 roles. I mentioned the product owner. That's the person who represents the business, the customer, or the users, and they make the decisions on what the priorities are. But then the other person is the Scrum Master, and this is usually not a developer, it's a coach. It's somebody who just makes sure that you're following the Scrum process and helps you when you've got problems with the process. And so you might have a Scrum Master that works with multiple Scrum teams is common. I've seen that a number of times. So that's just a little bit about Scrum. So going back, any comments, thoughts, experiences you've had with Scrum or Agile processes that raise questions?
One of the differences I see is that Scrum doesn't have that, well, at least maybe you haven't talked about it yet, but the customer involvement. Maybe
Right.
having one site or something like that.
Right. No, that's a great observation. So in XP, the customer was expected to be on site. You could ask them at any point for feedback and interaction. With Scrum, it's not so much that way. Usually you just have the customer interaction here at the beginning when you're establishing the sprint goals. And then at the end, I didn't mention that, at the end when you're done, the customer is the one who will accept the sprint as being the feature or user story as being complete. And so with every user story, you'll also have acceptance criteria. So how will the product owner know that it's done, and how are they going to judge that, yes, it's finished and it works correctly? And then
Right.
acceptance testing. Go ahead.
I was going to say, it seems a little bit more friendly towards the customer since they're not required to be burdened.
Yeah, I think that's one of the big reasons why Scrum is what's used so much now and not XP, because it is more reasonable for the customer. The other one was a little bit overloading for them. Even though it was a great idea in some ways to be able to ask them questions anytime.
I think it's better, but it requires a lot more coordination with the customer.
Yeah. And one of the problems with XP is the customer might be changing their mind all the time as they go. And with Scrum, you don't want that. Once that sprint has started, you lock it in. You say the the product manager cannot change their mind until this sprint is done. Okay, so you're saying, yes, we're accommodating change, but only in as frequent as our iterations are. Okay? So if they want more ability to change, then you have shorter iterations. Maybe just do 2-week iterations, and then they can change their mind every 2 weeks. Yeah. Whereas with XP, even though that was supposed to happen because the customer was there, often changes would happen mid-iteration, and that was dangerous.
Mm-hmm.
Hey, David, I'm just watching the clock, and I want to make sure you get a chance to review the PolyLearn things before the end.
Absolutely. Yeah, thanks for doing that.
But I was going to say one more thing. Last week, we went around and everybody kind of talked about their experience with software also related to their work, and it's a huge spectrum. There's Brad that works at a software company that, he is familiar with their agile process there, all the way to Perry, who makes a hardware switch where there's no software in the product at all. Yeah. But then a huge spectrum, and people had various experience, and not many of them recognized agile as part of their software development effort.
Okay. Thanks for that feedback.
Yeah,
that's interesting. In fact, I'm going to skip this last one, rational unified process. You can read on it. What I think I would like to wrap up with is 2 things. We're not going to do this walking through an SE project. So I'll just mention out there on PolyLearn, there's the only thing for today is the usual, the thing that the minute feedback that you give. If you can fill that out and give me some feedback, what was confusing, what was most valuable, that's great. There's a little bit larger reading due for next Monday, and so there's nothing due for Wednesday. But if you want to look ahead at that, and you can even skim those somewhat, but you might look ahead at some of that. But if we can use our last couple of minutes here, just what are some of the concepts, terms, software engineering things that you want to make sure that we talk about or you hear? Are there things that you hope for in the next week and a half as I'm talking with you? What could those be? And I'll just seed that a little bit with, I mentioned UML, the Unified Modeling Language. Last year when we did this, there was a lot of interest in knowing UML. It's a visual language for designing software, and it can be used to a certain extent in systems, and they have a version of SysML that has some similarity. So that's something I was planning on talking about some, just so you could read those diagrams and understand what's going on there. Is there interest in that? Is UML interesting? I see a nod.
Just because we were just talking about, the sprint process, I think the sprint review and the retrospective, I think are kind of cool concepts that you could apply outside of software too.
Yep, very good. Okay.
David, thinking about the systems engineering take and the interaction with software, it might also be really good for you to share with us what a good interaction with a customer looks like what characteristics about somebody that's coming with requests, how does that go well?
You bet. That actually fits real well with what I was thinking to do on Wednesday, is talk about how we do requirements. That's the primary way that we interact with customers, that you might interact with software people. And so what's a use case? What's a user story? What's the difference between those? What are user personas? What are functional and non-functional requirements? In particular, you guys are probably familiar with functional requirements, but what are software non-functional requirements? What are some of the things that we think about and we need to know from customers and the hardware people? We'll talk some about that.
I'm not sure if Charles is still online. Maybe he'll hop back on, and I think he was looking forward to the software, but I couldn't quite remember the details about why. So if Charles is still here, please speak up, Charles.
I am still here.
we use a lot of UML and SysML diagrams. We just going in further into detail, like you were just talking, David, would be helpful for me.
Okay, cool. Yeah, yeah. Yeah, we'll talk about some of the big ones. We'll start with class diagrams and activity diagrams, and then maybe we can look at state charts and probably do sequence diagrams, a couple more. We'll see what all, but yeah, we can definitely look at that.
Maybe the concepts of like a burn down chart or velocity, as far as that's kind of a different way to track progress than some of the other methods we've looked at in previous quarters.
Mm-hmm. Yeah, it definitely comes from the Agile world and Scrum. You bet. It could be applicable not just in software. Okay, those are helpful. I think I might talk a little bit about test-driven development just because that's an area of expertise for me, and I think there are some parallels in thinking in systems that you might have. Cool. All right, well, I think I'm good. Any questions about we'll be back together on Wednesday, and no particular assignment for Wednesday, but we'll have some things. Feel free to look ahead at the reading, and I'm going to have you create some UML diagrams over the weekend. Simple ones, really simple, but just wanted you to, get your feet wet, try it a little bit.
Any recommended software to do that with?
Yeah, I've got, and let me see if I can go back there. I have a assignment out here, UML class diagram assignment due for Monday, and I point to, let's see, thought I pointed to it. Maybe I have it back.
That's right there, Creately.
Violet?
Creately. Yeah, is there a link there? There's
It
also...
was already hyperlinked back there.
Okay. There's also here, there's a link. So Creately is one that you can use. There's a paid version, there's a free version. You can definitely use the free version. It has limitations, but you can't save your stuff, but you can make a screenshot of it. But there's lots of others out there. There's Violet is another one that's I'll put a link to Violet. I thought I had it out here, but I'll add that. Those are both simple ones and free ones, but you can use a wide range of things, even in the Office suite. What's the drawing tool there? Visio.
Visio, yeah.
Now, Visio has UML shape in it, and once you see what the shapes are and you see the UML section, you'll see it. And then there's some expensive, really nice, full-powered ones, but I'm not going to expect you to go look into those. We'll just use some of these simple ones. Good question.
You should be teasing us with the Jira board up there.
Oh yeah. We're gonna we're gonna come.
I see that. Am I back at work? Where did I go?
I know. So that's a good question. So at least one person knows about Jira. I'll show you a little bit around Jira, and we'll walk around some sample documents and what a project looks like. We'll try and do some of that on Wednesday.
Cool.
Yeah.
All right.
Okay, it's 6 o'clock. Thank you, guys. It's good to see you all.
Thank you very much.
Thank you.
All right. Bye.